There are various generations of mobile telecommunication, or you can say mobile networks, or mobile services, cellular services, data services. These are different generations: 1G, 2G, 3G, 4G, 5G. So the first generation was mobile phone system only transmitting the voice calls. There was only analog signals, no digital, no bits. Now you see here AMPS, Advanced Mobile Phone System. This was deployed in United States in 1982, and it was the widely used first generation system, 1G. This G stands for generation. Second generation, now it switched to transmitting voice calls in digital form. Okay, now digital came here. This was to increase the capacity, to improve the security, and then the text messaging was offered, texting. Then GSM. This GSM is actually a 2G system, global system for mobile communication, and this was deployed in 1991. 1G 1982, 2G 1991. So this is I'm showing how the phone used to look. 3G, this was initially deployed in 2001, and now it was giving both the voice and the data services digital. There's digital voice and broadband digital services. So ITU, International Telecommunication Union, they have specified 3G that if you're standing, you must get at least 2 Mbps, and if you're moving, walking, or in your train, you must get at least 384 kilobit per second. Mbps is megabit per second. This has to be the speed to call it as a 3G. And then UMTS. See, in between 2G and 3G, there is a time. So the CDMA 1 and GPRS, they all come in 2.5 G. We don't generally talk about 2.5G, but you need to know that there was 2.5G also. Some people have, they have researched on it. They have talked about it. So this UMTS is the main 3G system, which was deployed worldwide. And as we take the example of YouTube, say, there is some upload and there is some download. So this kind of thing, you can think that there is a downlink speed, 14 Mbps, uplink 6 Mbps. Now there is a spectrum, electromagnetic spectrum, and there is a radio spectrum. So radio spectrum, now for the 3G system, the spectrum or the frequency range is very scarce, is very short. Now why it is related? Because you need to talk on certain frequency. You can only talk on certain frequency. Mainly in the mobile telecommunication, you ought to use the frequency. Okay. Now this frequency or band, this is governed by the federal government. Like that is, the government has all the right. They sell it, that this is the range, and if you want to take this range, give us this money. So if you have a spectrum part, that is the licensed spectrum, so it becomes very easy to make systems and design systems according to it. Because at that particular spectrum, if you have purchased that spectrum, that is the frequency range, then you can make your own operators, design and operate the systems. But this costs a lot. This costs serious money. Let me take you to 2000. In United Kingdom, 5 3G licenses, they were auctioned by the government for $40 billion. I am talking about 2000. We are in 2022. So because of the scarcity of the spectrum, we have to do certain thing. So then came the cellular network. This cellular network has come just because of the scarcity of spectrum. There has to be done something to reuse the frequency. Okay? Because if somebody is talking and if other person is also talking, same frequency, there will be interference, and that interference, how to avoid that? So the coverage area of that base station was divided into certain cells. So if the division is such that there is a proper arrangement so that the two people talking may not interfere, or they may reuse the frequency. Okay. So within a cell, a user are assigned channels. For example, this A I am showing. all the A which you see here, they are in the same coverage area, but they do not interfere with each other and not also with the adjacent cells. These two, when they are talking, they don't interfere. So this is allowing, this way of reusing or cellular network dividing into cell resulted in the frequency reuse in the neighboring cells. And this is how the capacity of the network with a same frequency was increased. So this is the latest arrangement which we use. Frequency reuse is a very important aspect in cellular network. Along with this, the usage of different kind of antennas like directional antenna, like sectored antennas on the cell towers. This also helped in reducing the interference further. So these are all the way how we use these different G systems and frequency reuse. 4G and 5G. These are the 4th generation and 5th generation system. Why we are just discussing them differently? Because now we are only talking about the data. That is, the voice is also now on data. That is the 4G, which was basically 4G LTE, which actually became popular, the long-term evolution. This LTE 4G offers faster speed. And this came up in the late 2000s. And at that time, various technologies were there. But when this 4G LTE networks, they came, for the mobile internet especially, they outspaced the WiMAX, which was 802.16. WiMAX was a very popular technique, but it was overthrown by this 4G LTE. And 5G technologies, they are promising speed of 10 Gbps. And 2020s, many countries got it, and it's still under deployment. 4G, it uses frequency bands up to 20 megahertz. But 5G, they are designed to operate in much higher frequency ranges or bands, up to 6 gigahertz. See, 20 megahertz, we are talking about 6 gigahertz. That is this 6 gigahertz, that is a high frequency. Now, what are the challenges? High frequency means a lot of attenuation, a lot of interference. Because of this, newer algorithms are being made, the technology are being emancipated. That is, say, MIMO, multiple input, multiple output antenna arrays have come up. And the thing is that these short microwaves of this range of frequencies, they are easily absorbed by rain. So this is also one of the challenge which the designers are experiencing and working on.